Welcome to MongoDB World 2018. How have the morning sessions been so far? Great. Fantastic. We've got an absolutely packed ballroom, and I know there are thousands more watching on the live stream. Thanks to all of you for being here. MongoDB World is a learning conference. Each year we invest in putting together a technical program designed with the audiences represented here in mind. This year we have breakout sessions developed by MongoDB advocates throughout the community, by customer teams in organizations large and small, and of course, by MongoDB engineers. Our objective is that you leave these sessions with new knowledge you can take and apply to your own projects and in your own organizations. Now, none of this would be possible without the support of our sponsors. I'd like to thank all the sponsors, and especially our Bonanza level sponsor, IBM, our Diamond level sponsor, Google Cloud, and our Platinum level sponsors, Infosys, Microsoft, NetApp, TCS, and NASDAQ. Now, before we go further and get into the keynote, I'd like to take a moment and celebrate a milestone we hit yesterday. In my role at MongoDB, I lead the exceptional group of individuals that's responsible for developing and maintaining MongoDB University and the free online courses we provide. Yesterday, at about 4:45 p.m., a developer in Spain registered for our MongoDB Basics course. This course sign-up pushed us over the top to 1 million online course registrations all time on MongoDB University. I think this really speaks to the impact that MongoDB University has in helping individuals around the world learn to build with MongoDB. Okay, now it's time to get to this morning's main event. We have a keynote that's packed with new information and some really exciting announcements. So without further delay, I'd like to introduce the President and CEO of MongoDB, Mr. Dev Ittycheria.
Good morning. So the last 12 months for MongoDB have been truly a spectacular year. We've acquired thousands of customers. We've grown really, really quickly. We've made some seminal product announcements. And last October, we went public, the first database company to go public in over 26 years. So by any measure, it was a pretty good year. But you know what really hits home for us? What really hits home was when we connect with our customers and our community and hear the stories about how our technology is fundamentally transforming not only their businesses, but in many cases, their own industries. And so we've realized it's conferences like this that we really get our juices flowing. It's when we speak to you and you hear from us about where we're going and you tell us all the stories about how you're using MongoDB to solve important and relevant problems for your business. So then we decided last year, you know what? Why just do a few of these conferences? Why did we do a lot more? So we ended up last year basically having over 50 conferences all around the world in places like Bangalore, in Shanghai, in Sydney, in Tel Aviv, in Mexico City, and in many, many other places. And the stories we heard were simply fabulous. People all over the world using MongoDB to solve important problems for their businesses and for their customers. So when I thought about my keynote and said, what do I really want to talk about? I said, you know what? What's more powerful than hearing from customers themselves directly about how they're using MongoDB to truly transform themselves, to either drive more innovation in their business or fundamentally try and disrupt industries that we all know. So to that end, I feel very privileged to have 4 customers joining me on this keynote. The first customer comes from a company that's over 150 years old, an industry that's not necessarily known to be using cutting-edge technology. But this customer is very different, and they're charting a new course. So without any further delay, please join me in welcoming Jeff Needham from Travelers Insurance to the stage.
Thank you, Dave. I'm really excited to be here. You know, when we talk about database design, I think we tend to think relational. And we've been using this relational standard for so long that I think there's this notion that good database design and relational are somehow one and the same. And I think that's led folks, including folks in my shop, to be hesitant to move away from relational platforms. And I think it's important that we recognize that when we talk about the MongoDB document schema, we're not abandoning good database design. In fact, we're making it better. We're building on the last 30 years of relational, and we're taking our entities and our attributes, and we're storing them now in a far more efficient format than we did before. And I really can't overstate how transformative this database has been inside of our development shop. And moreover, I think this database is transforming the overall practice of information architecture. Last year at this time, we were here with you at MongoDB World, and there were a handful of us from my shop, and we were about to deploy our first 2 collections into production. And now at this time, a year later, or just under a year later, we've got over 120 in production, and we write over 10 million documents a day into them. Thank you. And I can tell you the time it's taken us to become proficient and effective with this platform in that short year has been incredibly short. And if I can summarize 3 reasons why we're really adopting MongoDB, it's first, JSON is the new SQL. It's dramatically simplified our storage and retrieval of information in our databases, and it's now allowing our developers to do more with less time. And with the aggregation pipeline, we get to shape that information in any number of ways now, giving us tremendous flexibility over relational. And secondly, this database scales with us when we need it to. Not only do we get high availability and high consistency at the same time, But we get to do something like scale at the speed of our business decisions. We can go from 7 million documents in production on one release to 8 weeks later, I go to 700 million documents in production without issue. And finally, as we move to the cloud, we know that our database will move with us, whether it's private, public cloud, or multi-cloud, or any combination in between. And that's a really big deal to our management team. So in closing, I'm really excited to be here again. Feel free to come find me afterwards, or even better yet, come listen to Mike Brosh and I at 4:20 this afternoon talk about how transformative this database has been inside Travelers Insurance. Thank you.
Thank you, Jeff. So what Jeff really talked about was why they chose MongoDB. Well, we hear from customers all the time about why they choose MongoDB, and let's put into our words what we hear constantly from people like yourselves. The first thing that we hear is that MongoDB truly offers the best way to work with data. So the second thing is that MongoDB truly allows you to put data intelligently where you need it. And the third thing is that MongoDB truly lets you have the freedom to run it anywhere. So I'm going to have 3 customers come up on stage to speak to these 3 points and how they're using it to drive their business. So let's talk about the first one, the best way to work with data. Now, for those of you familiar with MongoDB, you understand this very well, but the document model is simply the most natural, the most intuitive, the most flexible, the most versatile, and the most performant way to manage your data. We also offer a very rich query language, and embedded in the database is a very powerful aggregation framework. But rather than me talking about it, let me introduce our next customer. So this customer is in an industry that's fundamentally become one of the hottest spaces in tech, and frankly, in business over the last year. Some of you may already own Bitcoin. Yes, I guess someone already does own Bitcoin. But this, the cryptocurrency and Bitcoin market is one of truly the fastest growing and frankly fastest changing markets out there. It could have the promise of fundamentally changing how we transact and handle financial transactions. So please join me in welcoming on the stage from Coinbase, Luke Demai, software engineer.
Six years ago, when Coinbase's founders had the idea to create the easiest way to buy and sell Bitcoin, they feared they might be too late to the game. The Bitcoin network had already been in existence for 3 years, and there were multiple other competitors already in the space. So they optimized for technologies that would allow them to launch fast. Today, Coinbase is the most trusted cryptocurrency brand in the US, with over $20 billion in assets stored on our platform. Those initial technology choices turned out to be extremely important because the ecosystem has evolved dramatically over those past 6 years. The reason MongoDB itself was so important is because it allowed us to rapidly adapt to those changes. For example, we used to just be a Bitcoin wallet. However, over the past several years, we've added several additional products. We've added the exchange, support for several other cryptocurrencies like Ethereum and Litecoin, as well as institutional products like asset management and an index fund. Every time we add a new product, the document model makes it so easy for us to update our existing documents because of its sheer flexibility. Something you might not know about Coinbase is that one of our greatest challenges as an organization is preventing fraud on our platform. MongoDB gives us the flexibility to rapidly integrate with vendors to give us the insight we need to prevent those risks. Just last December, at the height of cryptomania, we were able to rapidly integrate a new identity vendor in just 2 weeks. Flexibility goes hand in hand with another benefit of MongoDB, which is keeping developers happy and working on the features that matter. As a Ruby on Rails organization, The document model reduces the impedance mismatch associated with working in an object-oriented world. At Coinbase, developers don't need to think before they interact with objects in our environment. As a result, we've prided ourselves on our ability to allow developers to ship code to production in days, not weeks. Over the course of the craziness of the last year, and if you aren't aware, 2017 was very crazy for crypto, MongoDB allowed us to scale to over 20 million users. I'm not going to go into too much detail now, but we're going to be giving a talk at 1:45 right over there, where we're going to be talking about some of the cool stories, techniques, and technologies we use to get us through that crazy period. The title of the talk is MongoDB and Cryptomania, so I hope to see at least some of you there. In closing, Coinbase is super excited about the future of MongoDB at our company, as well as all the product announcements that we're about to see today. If working at Coinbase or our mission is something that excites you, we're expanding rapidly. Wow, I did not expect a laugh there. But we are looking for you, basically, and we're always interested in talking to talented engineers. Please contact us. We have an email address set up called mongodb@coinbase.com, so email us or visit our careers page. We have positions, many positions open in New York, San Francisco, and London. So anyway, enjoy the rest of the conference, everyone. Have a good time.
Feeling that the career site's going to be getting a lot of hits lately. So the next point is all about intelligently putting data where you need it. Well, MongoDB has a very powerful set of distributed capabilities. Things like native replication and failover so you can have high availability. Things like being able to shard easily so you can scale your business as your apps and your users and your data volumes scale radically. Being able to do very clever things like run real-time analytics on production data. And also using zones as a way to position data carefully for the needs of your users anywhere around the world. But again, rather than me talking about this, let me introduce our next speaker. So nothing speaks to more to distributed data and scale than mobile computing. Obviously, it's almost a cliche to say that mobile computing has completely transformed our lives. But the challenge with mobile computing is for customers to reach out to those end users and engage with them in meaningful ways. So please join me in welcoming John Hyman, CTO of Brays, which was formerly called AppBoy, to the stage. John.
Thanks so much, Dave. This is actually my 4th MongoDB World conference, and it's always really great to be here. Now I'm excited to talk to you about how we use MongoDB at Brays. Brays is a customer lifecycle engagement platform. Our mission is to help brands use data to personalize and deliver brilliant customer experiences. And chances are, we're already in your pocket. If you've ever received a message from Lyft or Postmates about a promotion that you're eligible for, that's all orchestrated with Brays. When you get a push notification from Domino's Pizza telling you that your order's on the way, that's sent through Brays. And for those of you following along with the World Cup and playing along on DraftKings, those emails, push notifications, and in-app messages you're getting are all delivered through Brays. Each time someone downloads a mobile application that Brays is in or visits a website that we're on for the first time, we create a database record for that user. This lets us help personalize that user's unique customer journey. And we have nearly 10 billion of these user records. And what do we trust to store this data in? Well, at Brays, MongoDB is our primary database. Since 2011, we've used MongoDB to query and aggregate our customer audiences based on their demographics and consumer behavior, and that's been key to our business. We use MongoDB for geo-targeting. And we use MongoDB to define and store our customer journeys and schemas. In fact, later today at 3:30, I'm going to be giving a talk on how we do all this in MongoDB and going over our schemas. You're going to want to come. It's going to be a really good time. Now let me talk to you a bit about the scale of our product over at Brays. Across our customer base, we help engage more than 1.4 billion monthly active users every single month. We send upwards of 1.5 billion messages every day. Emails, push notifications, in-app messages, web messages, and more. So I've been up here talking to you for about 2 minutes or so. In that time, it's likely Brays has sent something like 5 million personalized messages to end users. And we do this with a massive MongoDB installation, more than 1,000 shards and replica sets. We process over 250,000 operations per second, and we do it on dozens of database clusters in the United States and in Europe. Each time we start working with a new customer at Brays, we essentially acquire their user base into ours and much of the user activity associated therein. So this year, it's likely that we're going to get to 2 billion monthly active users and 3, 4, even 5 billion monthly active users in the years to come. So as the CTO of Brays, it's my responsibility to ensure that we can continue to scale and meet that level of demand with the same high level of performance our customers have come to expect and that Brays is known for. And the good news is I'm totally confident that we can do it because we know how to scale MongoDB. We know that it can grow as fast as we're growing. We have dozens of customers with tens of millions of monthly active users. We have a handful of customers with more than 100 million monthly active users each, all of this backed by MongoDB. Because we know that MongoDB can continue to scale with our high volume of customer growth, it lets us focus on what we do best, building innovative features and helping brands deliver personalized, real-time, great, brilliant customer experiences. Now, we're really excited about our relationship with MongoDB, and we're moving some of our workload to MongoDB Atlas in the future, which I think you're going to be hearing about that in just a moment. So I'm looking forward to meeting you folks in the audience today, and I'll see you at my data modeling session at 3:30. Thanks so much.
Thank you, John. So you heard from Luke talking about the power of the document model, and now John talked about being able to be very intelligent and be able to scale your data at wherever your users or your customers are. The next point is all about the freedom to run anywhere. Now, many of you here are probably on some journey to the cloud. Some of you are maybe just getting started, and some of you may be all the way there. You're all in. But one of the key questions that we hear from customers is, what do they do? What does the future application architecture look like? And do they really have to spend a lot of time refactoring, if not replatforming, their existing applications? Well, one of the real benefits of MongoDB is you can truly future-proof your applications. You can build on MongoDB and run it on-prem, even on a mainframe. You can run in your private cloud. You can run in the public cloud, and you can consume it as a service. So our next customer is going to talk to you about their journey to the cloud. Now, this customer is in the marketplace business. The marketplace business has been very popular since the internet got popular. You know, we had companies like eBay build massive franchises where you could connect large amounts of buyers and sellers on the platform. And even today, you have companies like Airbnb and Uber who are doing the same thing. Well, this customer is actually focused on the job market, and in particular, the hourly job market, which is especially poignant as people look for high-quality and high-paying jobs in this economy. So please join me in welcoming Jason Ford from Snag, who's the principal engineer, who will speak to you about his and his company's journey to the cloud.
Good morning, everyone. So Snag is the nation's largest platform for hourly work. So that means that we build tools to help hourly job seekers find great jobs quickly and easily, and employers to manage and maintain their existing hourly workforces. We have about 90 million job seekers across thousands of locations in the US, and we run the core of our business on top of MongoDB. But that's not really anything new. We've actually been using MongoDB in production for about 7 years now. And we brought it in-house to solve problems that I think people are still using to solve MongoDB today, right? You know, we were concerned about the performance and scalability of our relational database system, as well as the speed of developers. And it's really been a gamble that's paid off. Developers have really enjoyed working with the software. We were able to totally get rid of our ORM, get rid of our database deployment process, and move ownership of the schema to each of our product teams. It's been one of the most stable and performant parts of our infrastructure, and we've been able to grow and scale along with the database itself, taking advantage of new performance enhancements and features as the database has grown. But as our business has grown, so has the size and complexity of our MongoDB deployment. From a single replica set, now we're managing terabytes of data across multiple clusters and managing a bank of MongoS's. And we realized that we were spending a whole lot of engineering time and effort managing and maintaining this cluster, time that we would much rather spend on more strategic work. So when MongoDB Atlas was introduced, we were immediately pretty intrigued by the prospect of this, moving to a managed system. But we had a lot of concerns. I mentioned that MongoDB was already running great for us. So if we were going to go through the effort of moving all of our data somewhere else, we needed to know that it was in the hands of somebody who knew what they were doing. I don't know of anybody better than the folks who actually write the database themselves. We liked a lot of things about Atlas 2 as we started to look through. We love that it supports TLS encryption. We love that it supports VPC peering to make connecting with our existing applications at AWS really easy. Having managed a large cluster ourselves for a while, we were used to a pretty low level of access to the database itself and had a good understanding of what was going on. So we liked that Atlas has really good monitoring features, real-time streams of data, and graphs not just on top of the database, but also on the underlying infrastructure still. So you maintain a really good idea of what's going on. We also liked that we were able to right-size our cluster and have it grow along with us. So we only needed to buy exactly what we needed and wouldn't get locked into, like buying a whole bunch of stuff we didn't actually need. So at the end of the day, like all things, it came down to cost, right? I mentioned earlier that we've been running MongoDB for a long time. What I didn't mention is that we were actually running on the community edition of the software, the free version. We're paying nothing for our database, the database software itself. So when we look to migrate, we had to take a pretty hardcore look at, okay, what is our current infrastructure and networking spend to run MongoDB in AWS ourselves, and what would that cost be in Atlas? And we were pretty pleased to see that thinking about what we would get out of it and running the numbers, it quickly became a no-brainer. I mean, especially thinking about things like, hey, like backups. We don't have to worry about those at all anymore. Backing up a distributed system can be tricky, and so just offloading that somewhere else was really appealing. We really liked that minor incremental security updates just kind of come in the background. We don't have to worry about those anymore. And major upgrades, which used to be a big project for the operations team, now it's just the change of a pull-down menu in Atlas. And it's that point that gets me really excited. I mentioned up top a little bit about what Snag is all about. We're not in business to be really good at rolling out a MongoDB upgrade across a big cluster, right? We're in the business of finding people jobs. So when I think about all the stuff we don't have to do, I started thinking about the things we can do, whether it's leveraging new database features or actually spending a whole lot more time with the data itself. How can we look at user behavior on our products and serve them more and more relevant jobs? Reducing that friction or that time, when you're nervous to need a job and then you finally get one. Because at the end of the day, that's what our business is. That's our mission, to put people in the right fit positions so they can maximize their potential and live more fulfilling lives. And running on MongoDB Atlas, I hope that we at Snag can spend a whole lot more time doing just that. Thanks so much for your time. Hope you have a great MongoDB World.
Thank you, Jason. So you had a customer who frankly was very committed to open source and frankly didn't want to pay anyone anything. And they basically said, when they looked at the value proposition of Atlas, it said it's actually better for my business to move my workloads onto Atlas than trying to do it myself. In fact, we believe that if you run MongoDB in the cloud, it's both technically and financially irresponsible not to use Atlas, given the way we've designed it and the way you pay for it. So what I'd like to do next is just give you a little bit of sense of what's happening in our business. You've heard from 4 amazing customers. Frankly, we have thousands of customers who are doing amazing things, and all of those customers are underpinned by innovative developers just like you here in the audience today. And that momentum is starting to show itself in a bunch of different ways. Stack Overflow, most of you know who this is, but if you don't, it's basically a place where developers go to hang out, learn, contribute, and so forth. They run an annual survey of all the developers and basically get a sense of, hey, what are you using? What programming languages, frameworks, application servers, databases? And they ask questions of what are you using today and what would you like to use? Well, the question they asked for the last 2 years was what is the most wanted database you want to work with? And MongoDB was the #1 choice for the last 2 years. And that's reflected in the number of downloads we see in our business. We've seen over 40 million downloads of our software. Now, to put that number in perspective, it is estimated that there's only 20 to 25 million developers in the world today. Now, that gives you a sense of how popular MongoDB is. And we've had over 12 million downloads just in the past year alone. And that also manifests itself in customers. You've heard from 4 customers from very different industries with very different kind of histories, but there's many more customers. I'll give you a couple more examples. 7-Eleven. 7-Eleven is, I grew up thinking of it as a brick and mortar company. They are reinventing themselves as a mobile commerce company using MongoDB to do so. Pitney Bowes, I remember them selling postage machines. They are reinventing themselves as a digital e-commerce company. And many of these companies, as you heard also from Jason, are using Atlas. We announced Atlas 2 years ago on this stage. At that time, Atlas was running in 4 regions around the world: East and West US, parts of Northern Europe, and the eastern part of Australia. But in the past 2 years, we've expanded from 4 to 54 regions around the world. It is truly the most widely available managed cloud offering or database service in the world. Now, why do I say that? Because it runs across Amazon, Microsoft, and Azure, literally in every corner of the world. And as they continue to expand their presence, we will follow them in every part of the world, places like Middle East and Latin America and even Africa. And Atlas is growing incredibly fast. 6 quarters ago, we only had 400 customers. Now we have 4,400 customers today. But a lot of customers told us, or prospects told us, you know what, Atlas looks very exciting, but it's a little awkward to start paying for something when you really don't have a chance to use it. We said, fair point. We created a free tier. And that free tier was launched last year. We quickly had over 10,000 users. Now we almost have 130,000 users on our free tier. And in terms of our global business, our business is expanding all over the world. Last year alone, we had 65,000 people attend 115 meetup groups around the world. Today, we have customers in over 100 countries. And in terms of employees, we now have employees in over 20 countries today, and that list is expanding. And you can also check our career page if you're interested. And so we're trying to expand our reach and touch every market out there. And one of the ways we're doing so is with our partners. We have a massive partner ecosystem. Many of them have sponsored this event. But we have partners like large technology companies, many ISVs and software companies who are basically embedding MongoDB into their core business or core product. Systems integrators, some of the largest in the world, who are using MongoDB to help businesses transform themselves and use digital technologies to enable a competitive advantage. And other partners who are expanding our coverage in parts of the world that we're not in today. And in terms of customer adoption, overall, it is growing very, very quickly. Our business over the last 4 years has grown 70% year over year. This last quarter, when you look back year over year, it's grown over 80% year over year. Now, we really appreciate the fact that customers are investing in us. Nothing makes us feel better to hear that. But with that investment, we're investing back in you. How do we do that? It's through research and development. Just to give you a sense, from 2012 to 2014, our research and development budget was roughly about a little over $60 million. Not an inconsequential number for a private company. But in the last 3 years alone, we have invested over almost $250 million in R&D. And those investments have yielded products like Atlas. Those investments have yielded announcements like a multi-document ACID transactions announcement, which you'll hear more about. And those investments also yield all the good news you're going to hear in the next talk. So I started this talk by saying the last 12 months have been truly a spectacular year, and they sure have. But when I see the opportunity in front of us, when I see what customers are asking us to do, when I see the power and momentum of our community, I believe we're just getting started. So to give you a sense of where we're going, please join me in welcoming my partner, our CTO and co-founder, Eliot Horowitz, to the stage.
Don't stop, make it pop, DJ blow my speakers up tonight. I'ma fight till we see the sunlight. Tick tock on the clock, but the party don't stop.
Transactions. MongoDB 4.0 will support multi-document ACID transactions. No, you're not on ACID. We are. And since transactions in Mongo are such a trippy concept, we decided it would be best to start off with an example of when you might use them. And to do that, we're going to talk about an e-commerce store. And we're going to come back to this e-commerce store throughout this talk this morning. So let's start by taking a quick look at how you might enter an order into an e-commerce store in MongoDB. So here we have a document, and this document represents an order, right? And it's got a list of line items as an array. And we're going to insert that into the orders collection. And then for every item we purchase, we're going to decrement the inventory in our inventory counter by how many are purchased. Pretty straightforward, makes a lot of sense, very clean. A couple of problems. One, what if the program crashes here? Right now we've inserted the order and not updated our inventory count. What if the program crashes here? Now we may have updated some of our inventory and not all of our inventory. Enter transactions. So in MongoDB 4.0, all you have to do is this. Right? You start a transaction, you add that transaction to all of your read and all of your write operations, and you commit the transaction. And everything either succeeds or fails, exactly like you expect. And that is sort of the first major point about transactions in MongoDB, and that they're incredibly familiar. They are just like transactions in any traditional relational database you've ever used. They're not some weird variant of transactions. They're not some cobbled together thing to make it sound like we actually have transactions. They are exactly what every person who's ever used a relational database would expect from transactions. They're conversational. You start a transaction, you do reads, you do writes, everything's off the same snapshot, everything works exactly as you'd expect, and they're incredibly fast. If you're not using transactions, there's no overhead whatsoever, and apparently when I've said that before, people assume that means that transactions are really slow. That is not true, they're actually quite fast. You'll be able to benchmark them soon, and we're going to be publishing some benchmarks in the next month or so as well. So we know that in 4.0, we're going to have transactions. So in 4.0, transactions are going to be supported on a replica set. So any replica set you have, you can use multi-document ACID transactions. In 4.2, which will be the next version of MongoDB, after 4.0, will support sharded multi-document transactions. So the work to get to transactions hasn't been short, right? We didn't decide a few months ago, oh, let's release transactions, that'd be fun. We've been working on this for a long time. And it all started with the acquisition of WiredTiger and the release of MongoDB 3.0. And as you can see, a lot of the stuff we had to build in order to get transactions are also things that the community really wanted. So for example, in 3.6, we introduced change streams, and we introduced retriable writes. Really great features on their own right, and also core building blocks of transactions. In 4.0, there's a lot more stuff coming as well, including obviously transactions to our replica sets. And there's a little bit left to finish to get to multi-document sharded transactions in 4.2. But we're actually very close. And in fact, the first unit tests working for sharded multi-document transactions are going to be coming in the next few weeks. So that's pretty exciting. So when should you use transactions in MongoDB? Right? Transactions in MongoDB doesn't mean you should take your schema from your relational database and just put it right on Mongo, where you're going to lose all the benefits of actually using Mongo if you do that. So let's look at some examples of when you should not use transactions and when you should use transactions. So now with transactions, you could take your relational model for storing orders and put it in Mongo, and you could make it work. Right? You could have take your tables, you have an order table and a line item table, and reference them together, turn those into documents, and use a transaction to insert that, right? But that is not the way you want to do it in Mongo. right? You want to have a single document. And we'll come back to exactly why a little bit later. And the beauty of Mongo is that in that single document, you can still do really interesting updates, right? You can still do interesting queries, you can still do interesting updates, right? You can still update every price in that line item array in a single operation. So that works. So when should you use transactions? Well, it really comes down to when there are distinct business objects. So an order in an e-commerce store and an inventory count, those are pretty distinct business objects. Two different users, if you're trying to transfer money from one user to another user, pretty distinct business objects. Line items in an array, not very distinct. Attributes of a user profile, also not very distinct. And that's sort of the way to think about it. The other time you want to use transactions, let's say you're trying to create some sort of an aggregate view of data. Maybe you've got some sensor data that's coming into MongoDB, and every time you want to insert into that sensor network, you also want to go and update some roll-up, some aggregate view. Transactions are a great use case for that. And one of my favorite that's coming in 4.2 will be that you'll actually be able to finally change the shard key of a document in a sharded collection. And so that's pretty exciting. So my general belief is that most users, above 50%, are going to use transactions, but for a very small percentage of operations. Right? Less than 1% of operations, I think, will actually use transactions. But the key is that you have the confidence to use MongoDB for applications where you might need them in the future. Right? Even if you don't need them today, maybe 2 years down the road, you're like, oh, now I need them. Well, now you have them. So transactions are coming in MongoDB 4.0. So, of course, the big question is when. We all know that patience is a virtue. And we all unfortunately know that software sometimes takes longer than we want. And sometimes in life you have to wait for the best things. But not today. MongoDB 4.0. MongoDB 4.0 is available right now. If you weren't in the keynote, you can go download it right now. So obviously, I was too excited about transactions to start this talk any other way, but I do want to welcome everyone to MongoDB World 2018. We've got a really packed agenda throughout the day. We've got a really great keynote for you. We've got a ton of interesting things we're going to be announcing, a ton of really cool demos, some fun surprises, and my goal is by the end of this talk that you'll actually have forgotten about transactions because of all the new stuff that we're talking about. I'd like to thank IBM for being our global sponsor, and I'd like to thank all of you for coming and spending the day with us. So let's keep going. So transactions. Right? Transactions are really interesting in isolation. No pun intended. And but what's really interesting, if you take transactions and you combine them with $lookup, right? $lookup is how you do joins in MongoDB, and we introduced $lookup about 3 years ago in version 3.2. So with transactions and $lookup, MongoDB is actually really good at reference relationships, right? Where you can store different data in different collections when you need to, and use transactions and joins to do your work. So it means that MongoDB is really good at two kinds of relationships, right? Reference relationships, where you're referencing things together, and of course, embedded relationships, right? Where you've got documents in an array. So it means that Mongo has two really powerful ways of modeling relationships between data. If we look at some of the traditional databases, they really have one, right? Everything in a relational database is a reference. And so they've built a lot of really great tools to make this work, right? Transactions and joins and all these sorts of things. But at the end of the day, what are you really doing? Right? You're really building an application on a bunch of spreadsheets. And we think that the document model and what you can do with MongoDB makes MongoDB the best database for relationships, right? You can embed things or you can reference them, and it really depends on what you need. And at the heart of everything at MongoDB is, of course, the document model. Right? The document model is the most natural way to store data. Right? You don't have to take your user profile and break it up into 75 different tables to store it. You don't have to disassemble your order in your e-commerce store and put it in different places. Right? You store things as they naturally want to be. And that's one of the most powerful things about the document model. You can change the schema when you need to. right? As things happen, you can adapt very quickly. But at the same time, we have features like JSON schema, so you can have database level enforcement of key attributes, right? So you've got as much flexibility as you need and as much rigidity when you need when you want that as well. And we've got by far the best query language for querying documents, whether you're just trying to do simple matching or aggregations, whether they're real-time or sort of batch analytics. And we give you a great idiomatic experience in any language. So we think documents, right, are the first of the three major reasons why MongoDB is such a great database. The second, of course, is distributed systems. And distributed systems are how we provide high availability, scale out, workload isolation, and zone sharding. And the third pillar is the fact that you can run MongoDB anywhere. You can have the exact same MongoDB experience, same development experience on any platform, whether it's a laptop, in the cloud, or on your own data center. You can move your application from one to the other incredibly easily. And you've got best-in-class security no matter where you are. So it's really these three things, the document model, the freedom to run anywhere, and distributed systems that make MongoDB the best application the best database for modern applications, for any use case on any platform. And so what we're going to do this morning is look at how in MongoDB 4.0, we're improving MongoDB in each of these areas. How we're going to make working with documents better, how we're going to make distributed systems better, and how we're going to make MongoDB run in even more places. So we're going to start off with the document model. So here's a document. It looks kind of nice. It's in the shell. This is a product and a product catalog. And what you'll notice is that it's all kind of together, and it's very easy to read because everything's in one place, so that's great. What if you're in development and you want to sort of play with the data to test various things out? What if you want to be able to edit a document in production because something's gone wrong? In the shell, it's a little bit annoying. So 3 years ago, we introduced MongoDB Compass. MongoDB Compass is a tool for developers or DBAs to go and work with their data. A lot of people are using it. A lot of people are very happy with it. But what we wanted to do in 4.0 is bring the Compass experience directly into the Atlas UI. So Atlas, as a reminder, is our fully hosted managed database as a service for MongoDB. Right? It's the simplest way to run MongoDB, the most elastic way to run MongoDB, and you can run it on any of the 3 public clouds. And so we wanted to bring that exact same experience right into the Atlas UI. And so that's what we've done. So now you have the exact same ability to work with your data, edit your data, whatever you need to do, whether you're in development or production, without leaving the Atlas UI. In order to show you how easy it is to use Atlas in order to work with your data, I'm going to invite Jonathan to give you a demo of the Data Explorer in MongoDB Atlas.
Relax, take it easy, for there is nothing that we can relax, take it easy.
Thanks, Eliot. As Eliot noted, you use Atlas so that you don't have to worry about the operational overhead of a database. But the benefits of using Atlas don't stop once your database is up and running. Atlas is with you throughout your journey with MongoDB, providing the tools you need to get your database up and running, and then your application out the door. Today, I'd like to show you some of the powerful features we've added to the Atlas Data Explorer to make it easy to interact with your data so that you can focus on developing your application. To get started, let's take a look at some of the capabilities available for databases and collections. I'm logged into my Atlas account for an e-commerce app our team has been working on, and I've navigated to the Data Explorer. Over here on the left, I can see all my databases and their respective collections. If I'd like to create a database, I can do so easily here. If I'd like to add a collection to an existing database, I can also do that. And if I'd like to drop a collection, I can do that just by confirming its name. But I'm not going to do that right now because that would probably annoy my fellow developers. That's enough about databases and collections, though. Let's talk about your actual data. Over here in the main panel, I can view all the documents in the products collection. At the top, we've also pulled out some key statistics that you might find useful. If I'm interested in performance, I can flip over to the Indexes tab. Here, I can view all the indexes that currently exist for the products collection. If I want to improve my read performance, I could create an index. Or, if I notice that an index isn't getting much use, I can drop that index by confirming its name to improve write performance for the collection. But the real power of the Data Explorer for developers is back on the Find view. At this point, the developers of our e-commerce app haven't had time to complete our product editing backend yet. If I want to edit our products, I could interface with MongoDB via the shell, but it's much easier for me to stay right within Atlas and interact with the Data Explorer here. So if I notice that there's a product here that we no longer carry, I can quickly drop it from the collection. And if I notice our inventory count is out of date on a particular item, I can update it here. If I'd like to create a new product, I could insert a document and create a whole new document from scratch. But it's much easier for me to duplicate an existing document and work with an existing template. So let's do that. Let's create the Condor Durable Kids jacket. So I've edited the name, and I'm going to update the SKU here. Now, of course, the Data Explorer wouldn't be complete if it didn't support the full suite of capabilities that MongoDB documents provide. So here we have a nested array of categories, and I'm going to add an array element for the kids category here. We also have a nested document of image URLs, and I'm just going to update these to match our new SKU. And since this is a new product, it's a new kids product, we're going to decrease the inventory for a limited run. And because it's a kids product, I'm going to jack up the price a little bit. I've been told there's a business opportunity I shouldn't miss out on here. So we can insert that document, and then if we want to view it, I can leverage the full power of MongoDB's query language right here in the search bar. So I'm going to search for all products with the kids category. And there's our product. Data Explorer is made to make it easy for you to examine and interact with your live data without ever having to leave Atlas. Back to you, Eliot.
Thanks, Jonathan. It's pretty cool to see how easy it is to work with your data directly in the Atlas UI. You don't have to go anywhere. So when is this available? Also today. You can use this. If you're in Atlas, you can start using it immediately. If you're not in Atlas yet, it's OK. You can migrate your replica sets or your sharded clusters live with almost no downtime. You can do that tonight. So what's next? So now you're looking at your data, you're playing with your data. What do you want to do after that? Well, the next thing you want to do with your data is sort of analyze it a little bit, look at it a little bit more deeply, maybe try to understand what's going on. And so for that, we have the aggregation pipeline in MongoDB. So the aggregation pipeline in MongoDB is very closely modeled after the Unix pipeline. I don't know about you, but I think the Unix pipeline is one of the greatest tools out there. It's a combination of little things that together are an incredibly powerful tool. And so I thought it'd be fun to take a look at one of my favorite Unix pipelines. So this is a Unix pipeline I've used many times. And what it does is it looks through a MongoDB log file and finds the slowest 20 operations. So we're grepping the log file for the timestamps, then we're sorting it, then we're taking the slowest 20, and then we're piping that back in so we can actually find the corresponding log entries to the slowest 20 operations. Pretty simple, pretty cool. The key is that it's easy to work with. And what makes it like that? And what are those same attributes in the aggregation pipeline itself? So it's composable. Right? You start with some data, and you just build little things on top of each other. Or you're building this as you go, which also makes it really easy to debug. Right? Because you can chop off that pipeline at any point, and it still works. You can still see what's going on. So very easy to debug. And it's incredibly powerful. Right? You can do almost anything with the pipeline. So this is that same query done in MongoDB aggregation. Right? You're looking at the logs collection, you're sorting it, you're taking the slowest 20 operations, and you're grouping it by query shape to see maybe what indexes you might want to use. So of course, we're enhancing the aggregation pipeline in MongoDB 4.0. So we're adding 3 new features. So the first one is date manipulation. So you can construct and destruct dates in your aggregation pipeline. So if you've got a string that you want to convert to a date or vice versa, you can do that. You can do string manipulation, so you can pull pieces out or do other sorts of various things. We all know that the dirty little secret in development is, half of development really is just string manipulation. So this will make that easier. And of course, if you want to pull numbers out of strings, the next thing you want to do is convert those strings to numbers. So we've added a whole host of type operators directly into the aggregation pipeline. But my favorite feature in 4.0 is actually a little different. My favorite feature is the aggregation pipeline builder we've built into Compass. What the aggregation pipeline builder lets you do is take a collection, in this case the orders collection, on the left, build out stages. Right? So here we've got a match stage looking for orders that are completed. And for every stage you add, it shows sample documents on the right. So as you add stages, you can see the output after every single one. So as you're editing your aggregation pipeline on the left, you see live results on the right, making debugging and iterating on complex pipelines incredibly easy. When we showed this around the office, people have been incredibly excited about it. So I'm super excited to show you how it all works. And to do that, I'd like to invite Asya to give you a demo.
Thank you, Eliot. Last year at MongoDB World, I showed you how you can build incredibly powerful aggregation pipelines to analyze the data right where it lives. And the best way and the easiest way to do that is to iterate over it step by step or stage by stage. I'm very excited to show you how much easier it is both for new users and for experienced users with Compass Aggregation Builder. As you can see here, I'm on the Aggregations tab for Compass, and I have a collection, and it's showing me a preview of some of the documents. Because the collection is not too big, I can turn off sample mode and be running my aggregations on the full data set. Here's where you find the stages. If I start typing a stage name, it'll show me all the matching stages. And because I have comment mode turned on, you can see that when I select a stage, it shows me all of the fields that it can accept, whether they're optional or not, and a quick description showing what they mean. If you need more help, there's a little eye here, which will take you straight to the appropriate manual page. I know that all the good pipelines always start with a match, so you can limit the data to just what you're interested in. And as I start typing the field, it does completion or suggestion for me. I'm going to limit this to category apparel. And as soon as I finish typing that, I can now see this is just the apparel documents. I can collapse the stages to get more screen real estate when I no longer need them. I can next do a group. Same thing, it shows me that I'm grouping on ID, so I'm going to group on product name. There it is. Tab over to the field, and I'm going to calculate average number of stars. So these are reviews. Here's all the accumulators. I'm going to pick average, stars, and there we go. We have a few that are 5 and a few that are lower. I could save this pipeline if I want to continue working on it later. But instead, I'm going to go to a different collection and show you a pipeline that I was working on earlier that I didn't have a chance to fully debug. So when I open this pipeline, it shows me all of the stages that I had already worked through. And to quickly review, it's looking at all the orders that are completed. So this is a report on revenue over certain dimensions. Products is an array, so we unwind it. We then group by state, year, month, and product category, calculating quantities sold, total revenue, different products. There's the intermediate results. We then keep going and do another grouping, this time by state and year, month only, to get the total revenue and an array by category. But I noticed suddenly that year, month here don't look correct. This doesn't look like what I expected to look like. I expected a year-month. So I can go back to my original data and notice that, oh, in fact, it looks like some of the older orders have seconds since epoch instead of an actual ISO date type. Well, that's not a problem because I'm actually running 4.0. So I'm going to add another stage right after match. I'm going to do add fields, and I'm going to call the field the exact same thing so it won't change my existing aggregation. And as I start typing 2, it shows me all of the conversions. There's to date, that's the one I want. date created. And now my preview shows that 1004 is in fact now a proper date format. I was right, these are all the orders. Now I can scroll down and see that where previously I was seeing some unexpected format, it all looks correct. I can now enable later stages that I earlier disabled because I wasn't ready to work on them yet. And I'm pretty much done. But now I want to actually transfer this to my code. My favorite feature here is export to language. Not because I don't know how to do it in a particular language, but it saves me a lot of typing. I can even include the appropriate import statements. I'm going to be doing this in Java, but of course there's other languages. You just copy and paste. Now, we don't have all of the languages covered here, but because Compass has a pluggable architecture, we would love to see pull requests from the community for the languages that we have not yet supported. So all these features are available to you, so please download, try the Compass Aggregation Builder, and see how it accelerates your analysis by natural workflow and real-time feedback. Thank you. Back to you, Eliot.
Thanks, Asya. I have built and debugged a lot of really bizarre aggregation pipelines over the last few years, and I cannot tell you how much easier it is with this tool, where you can just actually take a whole big thing, put it in here, work with it, play with it, and then just export it to a language and be done. So when is this available? Today. So download it, check it out. And do some really cool analytics on your data. So the MongoDB query language and aggregation pipeline are really powerful, right? They're a really great way to work with data. But unfortunately, in a lot of cases, they're hidden behind a layer that gets in the way. And so what do I mean? So let's imagine we're building the product catalog for my e-commerce store. So it starts off very simply, all right? I've got my products. Right? This is a typical e-commerce store. I've got my products over here, I've got my pictures. I'm building a REST API in order to query to display the product. So I've got an API URL right there. Right? So my api.swagstore.com/products. And I've got the corresponding Mongo query that I'm generating based on that REST API call. All right, so let's build this out. So the first thing I'm going to do is add a category filter. Okay, it's fine. I build the UI for that. I click the box. I add a parameter to the REST API, to the URL, and I dynamically build the Mongo query. It's fine, pretty straightforward. I'm going to do that for brand now as well. Okay, so it's kind of cool. Now this highlights one of the great advantages of the Mongo query language, right? Because you're building that query dynamically. You're not concatenating strings together to generate a query. You're just building that query dynamically because you're adding predicates as you need to. So that works really well. So let's keep going. So now we're going to add a price filter. So in a min and a max. So my REST API is getting a little bit more complicated, but a little bit more work to try and figure out how to piece this together. But we're all good programmers here. I think we can handle this. Now let's sort. Fine. A little bit annoying. I've got to add a sort field and an order field. I got this. Now some product manager comes along and says, well, what if you want to be able to sort by one thing and then another thing? All right, well now I've got a sort field, an order field, a sort to field, and an order to field, and I've got to go build all that logic in there, and it's getting kind of irritating. Because now every time I want to go and add some tiny feature to my UI, I've got to build the right REST API, I've got to write the right query in the backend, I've got to test all that, and it's kind of a pain. So can we do better? So what are we really doing here? Well, we're taking a really nice query language, right, MQL, and we're putting a REST API on top of it. And what we're kind of doing is we're basically building our own query language right inside of the REST API. It's not a great query language, it's kind of a shitty query language. Call that SQL if you want to make it shorthand. But wouldn't it be better if you could just do this? Wouldn't it be better if you could just build that Mongo query dynamically in the browser and send that query directly to the database? In the past, this is crazy talk. You got security issues and privacy issues and data governance issues. But we wanted to solve this. And so this is why last year we introduced as a beta MongoDB Stitch. Okay? Stitch is a serverless platform to help you build your applications. So what is it? Well, it's really a combination of services. So the two services we've talked about so far are Stitch Query Anywhere and Stitch Functions. Stitch Functions are simple, where they let you run JavaScript functions in a serverless way directly in the Stitch environment, and you can call these functions from an SDK or from other things, which we'll come to later, but they're little JavaScript functions you can just run directly in Stitch in a completely serverless way. And the other one that we're going to dive into right now is Stitch Query Anywhere. So Stitch Query Anywhere lets you write queries on phones, on iPads, on browsers, kind of anywhere you want, and send them directly to the database. And what happens is that query goes through an SDK, which goes through Stitch, which has an authentication layer and a rules engine, and then goes to your database in Atlas. So it's got fully integrated authentication. You can do custom auth, you can work with Google, you can work with Facebook, any sort of way you want to handle authentication, you can just do that. And the heart of this is a declarative rules engine that lets you declare in a very simple way, yet very powerful, who can do what, who can read what, who can write what, in a very clean way. And then it exposes the full Mongo query language. And those queries get pushed all the way down to the database, completely observing all the rules about the data that you specified. So what does this look like? Well, let's imagine we're looking at a user profile. So in a user profile, there's different kinds of roles. So you'll see the roles at the top. And the key here is the roles are not like mapped to a person. Just because I'm Eliot doesn't mean I'm everyone's friend. It'd be nice, but I'm not. So a user is mapped to a role for every single document uniquely. And you define how that happens, which I'll show you in a minute. So then for each and every document, you get mapped to a role. And based on that, you get different permissions. So the owner of the document, so maybe myself, I get to do everything. I can read and write every field. My friends can read and write comments, because I want them to write comments about me, because they're my friends. Hopefully they'll be nice. They can see my favorite bands. They can see my profile picture, but they cannot see my salary. Right? That's private. Only I can see that. Everyone, so people who aren't my friends, all they can see is my profile picture. And this is very easy to set up and use. And to show you just how easy it is to use, I'd like to invite Eric to give you a quick demo.
Thanks, Eliot. So today we're going to see how Stitch lets you easily and securely access data in MongoDB and work with it. So going along with your e-commerce theme that we've seen so far, something that you hopefully want to have in your app is users. And they're going to have a profile page, and you want them to be able to read it and edit it and probably just let them do it on their own, and no one else should be able to see it. So let's see how we can model something like that inside of Stitch rules. So if we go to rules, we need to add a collection first, because in Stitch, everything's secure by default. If you don't explicitly add a collection, we will not let you access any data. You have to specify how users can work with that data. So let's add the users collection. So we're going to be using the Swag Store database and users. The next thing we need to do is select a template. And what this is going to do is help Stitch be able to generate a rule that will change how users can view that data. And for this example, it's pretty simple. We just want users to be able to read and write their own data, and we have a template just for that. So when we select it, we need to put in a field name that Stitch is going to use to identify who owns that user document. And it's going to be identified by Stitch's user ID. So we're going to do user_ID. Now we're on this permissions page, and we have this role here, owner, which Eliot was just talking about. And for this example, a user can just read and write every field in the document as long as they're an owner. And the way that we detect that is this predicate here. And we're checking that the user_ID field is equal to the current user's ID. And if it is, they can also insert and delete documents. So let's actually see that in action. So in this third tab over here, I have the Stitch JavaScript SDK, and I am just logging into our app, and I'm getting a handle on our Atlas database. So let's see what's in the users collection. So I'm going to get the users collection, and I want to do a find and get everything. So it looks like we've got one document in here. It's mine. It matches my user ID. And I have an email. I have the last purchase I made. I got the user ID there, and an estimated net worth of $86. So I don't think that's right, but even if it was, I don't think users should be able to see that we're detecting that data about them. So let's see how we can get rid of that field. So redacting data in Stitch is really easy. You just need to add the name of the field. It's going to be estimated net worth. and we want to turn off writes and reads for it. So if you're a user, you can only see everything but that field. So let's go back to the tab and do a query again. So this time, we've got the ID, we've got the last purchase, but we don't have estimated net worth, so that's good. And when Stitch is redacting data, it's just for that user. We're not deleting any data. If we were to go to Data Explorer and just do a find again, we should see that, yeah, estimated net worth is still there, and we have other users as well. And if you notice, I was doing a find all, and I can still only see just the document that I'm allowed to own. So that's users. But that's a pretty simple example, and the rules can express much more complex relationships. And something that you might want as well in an e-commerce app is going to be a wish list. So if you have a wish list, you add items to it, and hopefully you have friends that will buy things for you. So you would add them to the wish list, and they can see what you want. So let's model that as well. So we're going to still use Swag Store, but we're going to use a wish list this time. And for a template, of course, we have another one that just works perfectly. And it's going to be that users can read and write their own data, and a user that belongs to a sharing list can read that data, but not write it. So we need a user ID again for who owns the wish list, and we need a field that represents who is the wish list shared with, and we're going to use shared with. So we add that, and this time we've got two collections here. We've got users, which has the permissions that we just set up, and we have wish lists. So when we're back on wish list again, we have an owner role, and that's going to be who owns the wish list, and it's selected by the user ID is equal to the current user's ID, and we have shared, and it's shared with you if your user ID is inside the shared with array. So let's see that in action as well. So instead of doing a find on users this time, I want to do a find on wish lists. So when I do that, we can see that there are two items here. Or two wish lists. We see the items that I want, and we see my user ID. There is also another wish list that has my user ID inside shared with. And this is my friend Alice's wish list. So I can see what she wants. Now, if I were to go to log in as her, she should definitely be able to see her wish list, but not mine, because I haven't shared it yet. So let's see that. Over here, I'm logged in as Alice. So let's do a wish list query. When I do it on this end, I can only see hers. And I can see her items, but she can't see mine, and she'll not be able to see it until I show her. So doing something like wishlist, sharing data with users is really simple in Stitch. There's not really much you have to do, and there's much more complex things you can do. So if you want to find out more about Stitch and rules, just stop by after the keynote, and we'll be happy to talk to you. Thank you.
Thanks, Eric. Now, Stitch Query Anywhere is actually really fun to play with. I like playing with it. I like playing with new things. But when we design Stitch Query Anywhere, it really has sort of as the gold standard application we wanted to be able to handle was patient medical data. Right? Can we design a rule system? Can we make it powerful enough that you can store medical data in it? So let's walk through how you could build a medical app right in Stitch. So in a medical app, you might have 4 different roles. Right, you've got a patient role, a doctor role, a nurse role, and an insurance agent role. And you have different kind of fields. So for the patient, right, they can read everything about themselves, but the only thing they can write is basic info. So that's things like name, address, phone number. They can't write anything else. The doctor can read everything, but all they can write, they can't change your phone number, but they can write diagnostic codes or notes or prescriptions, things like that. A nurse, all they can update is vital information, temperature, blood pressure, things like that. And an insurance agent, all an insurance agent can see is the basic info and diagnostic codes. So like the doctor's notes, what's actually going on with you, what prescriptions you're on, that's private, right? The insurance company doesn't get to know that. So this is kind of cool. You can imagine building this. But the really cool part here is, let's say you're the insurance company. So it's great. It's pretty easy to build an API where you only get a subset of the data out. But the key thing here is that that third party can now write an aggregation query and send that directly to the database. Right? They can write an aggregation query looking up diagnostic codes by zip code, right? And trying to sort of see if there's a problem in some area. Maybe there's a water problem in an area, and see if there's a certain diagnostic code that's popping up way more often in a certain zip code. And it's cool, they can do that without making a copy of the data. And this means that you control your data. right? You don't have people creating copies of it, synchronizing in other places, creating synchronization problems. The queries, the analytics people want to do are coming to you, and you get to control it. And we think that's really important today. So last year at MongoDB World, we said that MongoDB Stitch, we announced it, and we put it was in beta. We've talked about these 2 services so far. There's 2 more boxes we'll get to later. So when is this available? Well, I'm really happy to announce that Query Anywhere and functions are GA today as well. So you can go and start building apps using Stitch Query Anywhere and Stitch functions right now. So we've made a lot of progress, right? We can do really cool analytics. We can do analytics from anywhere. But very often, we want to do things and sort of get even more analysis out of our data. And maybe we want to do something in a more businessy way, right? Maybe some dashboards or some charts. And so MongoDB has done a lot of work over the years in improving how you can work with business intelligence and business intelligence software with MongoDB. So 3 years ago, we introduced the first version of the BI connector. And the BI connector lets you run MySQL queries using SQL directly against MongoDB. And we've made a lot of improvements in 2.5, which is coming out with MongoDB 4.0. We also recently introduced an ODBC driver. There's a wrapper around this. And the challenge with the ODBC driver was you should be able to go to Atlas, press a button to turn on the BI connector, and connect Microsoft Excel to Atlas in 3 minutes and start doing queries from Excel and pull that data in from Atlas. And that's pretty cool. And last is MongoDB Charts, right? A tool for building really nice dashboards and charts directly on MongoDB data without going through any other layer. So you can create really great dashboards that look like this. And to show you just how easy it is to connect Microsoft Excel to Atlas and to build really great charts and dashboards, I'd like to invite Grigori to come and give you a demo.
Thank you, Eliot. I'm super excited to be showing you some of the tools that our team's been working on. I love tools. Everybody loves tools, don't you? Yeah, of course. So first one, Eliot mentioned that you can connect your Atlas clusters through Microsoft Excel under 3 minutes. How about I do it under a minute? Hopefully everything works. So first, let's take a look at, at my Atlas cluster here. I want to draw your attention to this part here. You see the BI connector, the hosted BI connector is enabled. And that's actually that easy. If you want to have the capabilities of pulling your data through BI connector using SQL and one of your favorite BI tools, all you need to do is just switch that toggle. Then you can go and click Connect, and it will actually show you your connection string information that you will use to configure the new ODBC driver that we provide. It's just that easy. There's no magic, there's nothing special. You just connect, you just configure your ODBC driver. And oh, by the way, people who are running Windows, we have a version of the driver for you too, because how can you not? So I'm going to switch now to Excel. And here what you see is the vanilla workbook in Microsoft Excel. And I have already pre-configured my ODBC driver, so you don't have to see me typing in the authentication credentials, and went through the classic new database query dialog, and then inside Microsoft Query now ready to rock. So what am I going to do? I want to actually analyze our Swag store and some products and build some pivot table, right? Something that I can go and look and examine categories versus where the users come from. So I'm connected here to the Atlas cluster already, and I got to warn you. What you're about to see might shock you a little, because your beautiful, your harmonious, your rich documents with all the embedded relationships are going to be flattened and brutalized, but not for life. So there you go. Take a look. Ah, there you go. You see that? All of the embedded... Oh, you're not shocked yet. OK, good. So all the embedded fields turn into a separate table, right? So now, if I want to really analyze them together, I actually have to execute a join. Well, again, if this is, well, not that. If this is your favorite choice, we're going to support you in that too. Let me just grab my join. And I'm going to return the data as a pivot table. This is actually where Microsoft Excel shines, right? So if I click this, you're going to see I got my pivot table. Now I can go and grab these categories and pull them onto my row. I'm also going to go and grab the user state, do the same, and then I'm going to go and do some calculations on the number of orders. And just that easily, in a few clicks, I was able to build a pivot table in Microsoft Excel, pull in data from MongoDB through BI connector and the new OGBC driver. How did I do? Was it under a minute? So there's still, thank you. So apparently there is still a place in the world for tables. Pivot tables work great. All right, well, now this is good and jolly, and I'm happy to show this, but that part where we're flattening the data is bothering me a bit. Can we do better? What do you think? Well, yes, you say, Grigory, go ahead, use the aggregation framework. That one is powerful, robust, it can actually do all of that. But how about if I want to build the visualizations that are interactive and collaborative, and I actually don't want to write any code? I don't want to write any code. Well, the answer is MongoDB charts. So I'm going to switch to the charts now, and you can see here, right there, I am in my MongoDB charts list of dashboards. I'm going to build a new dashboard very quickly. And I'm going to go and build a new chart. I'm going to add a chart. What I'm going to analyze, I want to do something around my revenue for the Swag store, right? So I want to know how I'm doing over the period of time. I have already onboarded one of the data sources, the one that you've seen we were using earlier, and actually Asa used in her aggregation pipeline builder demo. And you can see as soon as I had picked my data source, charts is smart enough to analyze the schema and to offer you the fields that are available. And now I can just go ahead and drop them on the axis by dragging and just that easily. I'm actually going to do that here. Go away. And I'm going to grab the totals and put them on the y-axis. And that's it, right? Just a couple of clicks, I've got my first chart built. And again, I'm very happy that Asa had wrangled with that data and cleaned it up so that I can actually have the appropriate type. Because charts is smart enough to recognize the type of the fields and then to offer you the treatments that are appropriate for the data type. So you notice that it actually already been binned by month. Well, what if I want to know which of my day of the week is the most active? I can just go and switch like that. Look how beautiful. So now I know over a period of time, it seems to be the trend that Thursdays are the busiest for my Swag store, and I should probably be ready for that. Now, this is all great. How about we make it a little bit even more interesting? What if I want to get insights like this, but I want this to be categorized based on the products? Well, I can actually go and grab the product category. Luckily, I have the rich data model here. So I'm going to grab this and move it into the series. And look what just happened. This is the moment where MongoDB charts truly shines. Okay? It recognizes that this is an embedded field. It recognizes this is an array, and not just an array, but a nested array, 2 levels. And it offers you different ways how you can handle it. Well, look, I can just go ahead and unwind it. Actually, why not do that? And on the category, I can do other things. I can calculate some stats. I can unwind it. Or in this case, I'm actually going to use this array element by index because I happen to know that the way this data set was modeled is that the categories, while being an array, actually represents an embedded hierarchy of categories. And I want to have the granularity in the second element. So I'm actually going to specify 1 since it's 0-based. And just that easily now, look, I've got the same information, but now categorized by products, and looks like the blue category is the most popular. Well, I actually going to switch to the stacked version, and you can see that this is something that's now giving me the type of insight I was looking for. This looks pretty great. You have a whole bunch of other types for charts that you can build. I'm going to just save that. I can go ahead and reposition it on my live real-time dashboard. I can build more charts. I can even go ahead and share my dashboard with other users. And just so you can appreciate the richness of different charts that you can build with MongoDB charts today, I'm going to share with you the Swag Store Rhythm of Business dashboard that I built for you. Look at all these different informations that I can visualize easily in different forms, heat maps, donut charts, and so on, scatter plots. This is just beautiful, isn't it? The most important thing is that you don't have to send your data off anywhere. This is native data visualizations on MongoDB. We're very, very, very quick to insight. So happy charting. Thank you, Eliot.
Thanks, Grigori. I bet everyone here has some data in Mongo that they wish they could build a chart on. And so MongoDB Charts is in beta right now. You can go download it, spin it up in about 5 minutes, and go out and just build a chart. And I would encourage everyone to do that and then send us feedback and let us know how it's going. So we've talked about a whole bunch of things. We've talked about a whole bunch of things this morning about how we make working with documents better. We talked about how have a full CRUD experience directly in the Atlas UI. We've talked about the Aggregation Pipeline Builder to make it really easy to build and debug complex aggregation pipelines. How Stitch Query Anywhere can make it much easier to build applications. And all the cool things you can do in analytics, including ODBC and charts. So now we're going to move on a little bit. So now we're going to move on to distributed systems and what MongoDB is doing with distributed systems. So first, let's take a look at sort of the four main benefits of distributed systems in MongoDB. Right, so you've got high availability, so that no matter what happens, if machines crashes, data centers crash, regions crash, you're fine, MongoDB is up. How we have scale out, so you can scale out to any size workload that you need. How you can do workload isolation and isolate different nodes in your clusters for doing transactional workloads or analytical workloads so that you can actually make sure that your analytics traffic doesn't impact your transactional workloads whatsoever. And zone sharding, right, that lets you put data in different places. And zone sharding is one of my favorite features of Mongo. It's actually been around for about 5 or 6 years. And what it lets you do is configure where data lives around the world based on a set of policies. So why might you want to do this? Well, one is maybe you want to keep certain data in certain countries so that everyone has a really good experience. Right? If your Australian users want to write their data, why should they have to go all the way to California or New York to write their data? Maybe you need to keep certain data in certain places for regulatory reasons. You want to keep your American data in the US, you want to keep your data for German citizens in Germany, for Australian citizens in Australia, and so on and so forth. So you can imagine if you were a MongoDB user, you might start off with a single data center somewhere on the east coast of the US. And then what you might do is, okay, well now I really need to follow some European laws, so I want to keep my German data in Germany, and maybe I want to keep most of my data for Europe in Europe and do it this way. But then I notice my Australian users are having a really poor experience, or I want to, there's some new Australian law that says my Australian data has to stay in Australia. So you go and you want to go and build a new data center and set up a new region in Australia. And you can do all of that with zone sharding. The challenge with zone sharding historically is that means you've got to manage a very large global cluster of MongoDB. Configure it, maintain it, and work with it. So we thought it'd be really cool if you could actually go to Atlas and build one of these clusters in a matter of minutes. And so we built that. So in Atlas, you can now go build a cluster that spans the entire world in about 5 minutes and accept reads or writes in any geography in the world. And to show you just how easy it is to do that, I'd like to invite Andrew to give you a demo.
Trucking, got my chips cashed in, keep trucking, like the Doodah Man together.
Thanks, Eliot. I'm super excited to show you what the team's been working on here. So I'm going to start out in the MongoDB Atlas UI and enter the Build a New Cluster experience. To recap where we've been since last year, we can select a target region, and we can deploy a cluster there. In a few clicks, we can, after deploying that cluster, actually change its region, and Atlas will move it for you with no change in connection strength, no downtime. We've also had the ability to introduce read secondary regions for high availability and for enabling lower latency reads for users in other parts of the world. But today, we're taking it to the next level. I'm going to click on the global cluster configuration. Here we can see a beautiful new map we've introduced into the UI. that with these colors shows us the approximate write latency from users in different parts of the world to our target cluster. Here are clusters in Seoul, so we see brightly lit users in East Asia who have a great experience. They can write at very low latency. Users in the Americas and in Europe, when they do those writes, they're going to be waiting. And when users wait, we lose them, we atrophy them, and that hits the business. That's not acceptable today. So let's scroll up and enable global writes. This capability is available on AWS, Google Cloud, and Microsoft Azure. We provide easy-to-get-started templates that are fully customizable to help us understand how this works. I'm going to go with the simple global performance template for now. Here we can see that the Americas countries are mapped to the US East region, EMEA mapped to Frankfurt, and APAC to Singapore. This is that canonical 3GEO cluster, global. The sun never sets on the writes for this cluster. Now, I think a lot of folks will start here. That's the easy starting point. But you can grow into regions over time. So I'm going to go back to the zone templates and show you the excellent global performance option. You could have introduced a couple of regions and end up here and now have excellent global latency for the vast majority of the world's population. This is fully customizable. So if I wanted to move my APAC North region to, let's call it Seoul, I can just change it, and we'll see that reflected on the map. If I zoom into North America, we'll see that we've actually mapped the western states and provinces to US West, and the eastern states and provinces to US East. We do all this for you. So let's see what it looks like in a couple of minutes after we deploy this cluster. It looks like any other Atlas cluster. If I click into the connect experience and find my connection string, we'll find a simple, concise connection string that we can use in all of our globally deployed application instances. Symmetrically, we can deploy them, making that easy. Now, I think the magic here, the aha moment, comes from looking at the data itself. So let's jump into the Data Explorer. With global clusters, if I create a collection, it's called Hello World because that's appropriate here. Atlas is going to walk us through the setup of the shard key. It's going to be a two-field key. The first field is called location, that's set for us. And the second field we choose. So I'm going to go with the user ID. After I've created this collection and inserted some documents, here's how it might look. The key here is that all I had to do to make this work is include in this location attribute in my document a 2-letter ISO country code or subdivision code. Doing so will automatically ensure that that location affinity is baked into the document, and Atlas will ensure that that document goes to the nearest zone. It's as easy as that. So here we see KR for South Korea. That's automatically going to be mapped to that Seoul region. US-NY, New York State, automatically going to US East. DE, Germany, automatically going to Frankfurt. Very powerful. Now let's imagine that we've grown into having customers in a new part of the world that we perhaps didn't serve with as much focus as before. And let's say we're starting to get real adoption in India, for example, or South Asia. At any time, I can go into this editor and simply add a new zone. In this case, I'm going to select the Mumbai region for this zone. And if I scroll back to the map, we'll see that Atlas has simply remapped those South Asia countries to this new Mumbai region, automatically for us in that orange color. And when we deploy this change, those documents previously tagged with those countries will simply be in the background in a graceful manner moved over to that Mumbai region. No downtime. If we need to scale the write throughput of a particular region, for example, if US East is actually where we have the most traffic, we can simply increase the number of shards we allocate to it. By default, it's 1. Change it to 2, and we've doubled the write throughput of that region. Now, we've been mostly talking about giving users those low latency in-region writes. and keeping data near users and having it not leave their region. But there's another use case to consider. These days, users expect social experiences, and they expect to be able to engage at low latency, not just with their neighbors, people in their own region, but with a global audience, everyone else. So with a single click, we can configure local reads in all zones. This will add a read replica from every zone and every other zone. That gives us a global cluster with global writes and global reads with low latency. Fundamentally, this is a global operational data layer. Folks, there are 4 billion internet users today in this world. You don't have to be a household name internet brand to meaningfully reach them any longer. You can reach them right here in MongoDB Atlas. We're super excited to see what you build with this capability. Thank you so much.
Thanks, Andrew. And I just want everyone to think about what they would have to do if they didn't have global clusters in Atlas, and if they didn't have zone sharding in MongoDB, what you would have to do to build something like this. You'd have to spin up clusters all over the world, figure out how to move data around without downtime, and figure out how to do queries across every single cluster. It's kind of daunting. So when will this be available in Atlas? Today. So you can go home tonight, spin up a cluster, spans the entire world, and no matter where your users are, have them do writes incredibly quickly. So a couple really great things in Atlas. So the next thing we're going to talk about in distributed systems is something that came out in 3.6, which was change streams. So change streams are how you get real-time notifications out of MongoDB to do whatever you want with them. Right? You can use change streams in order to send text messages or update other data systems because you're listening to events happening in the database. And the code to use it is pretty simple. Right? So this is the Python code that lets you watch all operations on a collection. So you can look for all inserts or replacements, and you can iterate that collection. It's resumable, it's restartable, it works pretty well. The challenge is you still have to go and run application servers to do it. You still have to persist this resume token. You still have to monitor and manage this service. So we thought it'd be great if we turned that into a service. So the third box on the stitch diagram is stitch triggers. And stitch triggers does exactly what you think it does. It lets you execute JavaScript functions inside of Stitch when things happen in the database. So when a document gets inserted, you can configure a JavaScript function to execute that can do anything you want. So what might that look like? Well, maybe you send an increment update to the database. Send that to Atlas. Atlas is going to go ahead and execute a function in Stitch. It's all serverless, all fully managed. That JavaScript function is going to go send a text message to Twilio, and it's going to pop up on a phone. And to show you just how easy it is to get this working and how quickly you can add real-time events based on database actions using Stitch triggers, I'd like to invite Jane to give you a demo.
Thanks, Eliot. It is amazingly easy to get started with triggers and set up real-time notifications in a distributed system without really writing tons of code or setting up application servers. And so we'll discuss today two main cases for using triggers. The first being updating application users about their data changes. And the second is updating other systems and other collections and propagating your database changes based on how your data changes. So to do that, let's take a look at two examples. We'll take a look at orders and we'll take a look at inventory. We'll see exactly the example that Eliot just described. So we'll see how we can quickly send text messages and other notifications. We'll see how we can run data analytics and really update your other systems based on how your data changes. So let's find an order. So let's find a product that is currently out of stock. So I have here my products collection, and I'm going to go ahead and find something that is currently out of stock. And we'll let our users watch items that are out of stock, and get notified with a Twilio text message when the item is back in stock. So I found an item. It's a MongoDB leaf luggage tag. I'm going to go ahead and grab that item ID, and now I'm going to go and find my user document. And I'm actually going to need that item ID because that's how we're going to construct a text message, and that's who we're going to send the text message to. So we'll need to do one thing. We'll need to insert that item ID into my notification array right here, and go ahead and update. And then once that happens, let's go ahead and actually set up our trigger. Now, triggers are amazingly easy. And actually, behind the scenes, when you create a trigger, Stitch will go ahead and set up a change stream. It will monitor it for events, and it will resume it and update it whenever you update the configuration. So super easy. So here, we'll specify details such as our trigger name, and we'll tell it which collection to watch and where it resides in which database. Now, the operation type of trigger will determine the kind of event we're interested in being notified about. And in this case, we're interested in a notification based on a change in a field in our database. So I've specified an operation type of an update, and I also want to replace because I'm going to be making these changes through Atlas. Now, triggers have the ability to return the full document. And in this case, we actually want the full document because we want to construct a nice text message with a product name in it. But I actually don't have to specify that, and I can disable the option and make my events more lightweight and my triggers even more performant. That goes in hand with a match expression, which is an advanced option I've specified here, because I actually don't want just any notification about inventory. I want to be very precise about this. And all I want is to be notified when an inventory goes from 0 to a number greater than 0. And that's the aggregation expression I've specified here. So the core logic actually resides in my function here, notify users. So let's go ahead and take a look at that function. So that function that I've predefined here will actually receive the full event, which will contain my entire product document, and then it will do two things. It will card the product right here, and it will text the user using our Twilio service integration. Now, another thing that I'd like to point out here that you may notice is I actually have my entire user application context available here. So that's super helpful and something that Stitch Triggers allows us to have. So I can do things like update the database right here, or call a helper function right here, or use a third-party service right here, all in just a few lines of code. So now let's actually go ahead and simulate the restocking of this product. So when I make this change, what I'd like to have is I'd like to see my phone screen up there so that once I update this, we can watch my text message come through. And this is a real phone right here, folks. So live demo, anything can happen. Total moment of truth. Hold your breath. All right. Right? This was pretty cool. There you go. So just like that, 0 application servers to set up, about 40 or so lines of code, and we've built a real-time application using Stitch Triggers. So for my second example, what I'd like to do is, I'd like to still send a notification, but this time I actually also want to run a bit of analytics using my trigger so that my swag store can receive up-to-date numbers based on the most up-to-date sales that we've collected this quarter. And my notification will be about a shipment of an order. So let's go ahead and take a look at our orders collection. And this time I want to find an order that's currently in process, and I want to be notified when that order is shipped. So let's take also a look at our current quarter sales and find that in our sales reports. And I'll note that I've collected so far $1,000, and I've sold 200 items in my swag store. So that's what I'm going to want to update. So now let's go ahead and set up our trigger again. This time we're going to be watching the orders collection. And as before, I also want an update or replace, because again, I'm going to be modifying an order document. And I'll want the full document again, because I actually want those order totals in order to update the sales report. So in this case, I also want a match expression, because I'm not interested and any other notification other than the shipment. So I want to ignore everything else except when the status is changed to shipped. So that's great. And before I take a look at our linked function here, an important thing to point out that unlike sort of traditional database triggers that are known to be dangerous, the compute that Stitch uses to run the trigger and to run this function when the trigger fires is completely separate from the database. So you can actually specify very complex functions without affecting your other database workloads, which is super important. So now let's take a look at that function and actually notice that that function calls two other functions. So it is more complicated than the first time around. And the other thing to point out here is that we're taking full advantage of promises in ES6, and this is something that Stitch allows us to do, which is super important when you're coordinating various services across your infrastructure. So now let's go ahead and take a look at those two functions. One will send the order confirmation using our Amazon SCS service integration, so I'll receive an email. And the second one will update my receipts and my units sold with the orders total and the order units from my order. Now, of course, in the real world, the analytics and the aggregations are going to be much more complex, but this sort of illustrates the general point of what triggers can do. So let's go ahead and simulate the order being shipped. And this time, I'm going to edit my document once again. I'm going to send my status to shipped. I'm going to update my document. And what I'll notice also that my order was $218 and 2 units. So that's, and here's my product that I'm going to be expecting in my email. So let's go ahead and see if we've indeed received an email notification. Ta-da! So here's my notification that my order's on its way. Contains exactly the products that I was expecting. And now let's go ahead and take a look at my current quarter sales. Now notice when I update this, what should happen is my receipts should be incremented by $218 and my units by 2 units. So let's do the refresh again and notice that that is exactly what happened here. And there you have it, folks. So 0 application servers, super simple, super straightforward, and we've enabled real-time applications. We've enabled complex data propagation. We're very excited to see what you are going to build with this. Please stop by our booths, ask us questions, and back to you, Eliot.
Thanks, Jane. So it's really cool how quickly you can go and build this. So if you're in Atlas today, and again, you can get there quickly if you're not there already, you can have a Stitch trigger up and running in a matter of minutes. And you don't need to use any other part of Stitch to use Stitch triggers. You can just use Stitch triggers just to do interesting things. You can use it to listen to inserts from a sensor network and like have a red light flash when a temperature goes over something. Maybe you want to send emails when an order is shipped. Or maybe you want to when a document gets inserted into Mongo, maybe you want to go and trigger a Kafka or Kinesis stream. Or maybe a document gets updated in Mongo and you want to update some other database or some other collection. All incredibly easy to do using Stitch triggers. So we've talked about how Query Anywhere is GA today and functions are GA, Stitch functions are GA today. So what about Stitch triggers? Also GA today. So you can actually, literally within 15 minutes of the keynote, you can actually go and get up a Stitch trigger and have things happen in real time based upon database events in MongoDB Atlas. So we've talked about 2 things in distributed systems. We've talked about global clusters in Atlas, and we've talked about Stitch triggers. So pretty cool stuff that you can try out right now. So what's next? Well, the next is the fact that you can run MongoDB anywhere. So let's see what we're doing there. So MongoDB Atlas, we already talked about how you can run that anywhere. And Dave mentioned earlier that we added a free tier to Mongo Atlas about 1.5 years ago. So we're really excited to announce that today, also available today, is actually a free tier available on Google Cloud. So now you can spin up free M0 clusters in MongoDB Atlas on either Amazon or Google in a matter of minutes. And these are just free tiers that you can have forever to store 0.5 gig of data and do whatever you want with. So that's available today. The next thing I want to talk about is something that we're working on that's coming a little bit later this year, which is all about cross-cloud. And cross-cloud is kind of interesting. So what we're doing with cross-cloud is we're actually going to let you build clusters in Atlas that span all 3 major public clouds. So why are we doing this? One, is so you're not locked into any public cloud. You're able to actually migrate from one cloud to another with a few clicks. 2, let's say you're using global clusters, and you're using one cloud provider, and there's a region that you really need to go into, and the cloud provider you're on right now doesn't have a data center in that region. Well, with cross-cloud clusters, you can just use a region from a different cloud provider. Same cluster, same everything, same security setup, it'll just work. Maybe you really like the transaction workloads, and you really want to keep all your transactional workloads in one cloud, but you really like the machine learning algorithms of another cloud. You'll actually be able to have your main cluster in one cloud and spin up secondaries for that same cluster in a different cloud so you can do machine learning and not have to have data transfer to the public network every time you want to run a new test. All incredibly easily, all coming later this year. So the next thing we're going to talk about, we're going to move away from the public cloud and move into the private cloud. Right, everyone we talk to who's running in their own data centers wants a private cloud experience in their own data centers that's as close as possible to what's available in the public cloud. And it's become very clear to us that the winner in that space is Kubernetes. Right? Almost everyone we talk to wants to run Kubernetes as their private cloud environment. And that could be vanilla Kubernetes, it could be Kubernetes with OpenShift or Cloud Foundry, but Kubernetes is at the heart of almost every private cloud customer that we're talking to. And so what we've done in MongoDB 4.0 is actually integrated Kubernetes directly with Ops Manager, so you can incredibly easily use MongoDB and Ops Manager with Kubernetes to spin up and manage your MongoDB clusters. And to show you how that works, I'd like to invite James to give you a demo.
I'll be the roundabout. The words will make you out and out. I'll spend the day.
Thanks, Eliot. Today I'm going to show you just how easy it is to spin up MongoDB clusters on Kubernetes. Using the new Kubernetes MongoDB operator, I'm going to declaratively define the config for a MongoDB cluster, pass that to the operator, and the operator will take charge and deploy MongoDB for me. Operators are a new type of Kubernetes service which enable managing applications running on your Kubernetes cluster. Once I've defined a MongoDB config, I'll pass that to the operator. The operator will then have Kubernetes assign appropriate pods to run the cluster on, and then Ops Manager will deploy the MongoDBs inside of those. Here's a replica set I deployed earlier. Let's have a look at the config I used to do that. So over here, we have a very simple config for deploying a replica set on Kubernetes. You can see I've defined the kind here as a MongoDB replica set. This is a custom resource definition, which we've defined, which lets Kubernetes know that the operator should be in charge of this config. Down here, I've asked for 3 members, MongoDB version 4.0. And down here, I've defined some project information. This relates to the project in Ops Manager that the MongoDB instances are going to be put inside. I've got my credentials down here, which are stored inside of a secure Kubernetes secret object. Finally, just for testing, we have this persistent false flag. This is just for ease of demo, and it means that persistent volume claims won't be created. Later in the demo, we'll be talking about some of the options you can set on those persistent volume claims so you get the right kind of storage. But this replica set is deployed today, but over time needs change. Let's say you're an online retailer and you know you're coming up to a period where you need more read traffic. You might want to scale up your replica set. So let's have a look at what I'd have to do that. So over here, I'll switch to the same version of the config. The only difference is that members have switched from 3 to 5. I can take that config and apply it using the Kubernetes command line. I can also do this using the Kubernetes APIs. I'd enter over there, and here in the Kubernetes dashboard, we'll have a look. The pods have already been allocated. So you can see here we're using Kubernetes stateful sets. These have a number of really useful properties for persistent storage, and we're using a lot of underlying powerful Kubernetes idioms to provide this integration. If I go back to Ops Manager and look at the Agents tab, you can see these host names have been constructed out of both the name of the replica set and then an index. These are totally predictable and stable. If one of my pods get descheduled for some reason, for instance hardware failure, replacement pods will be spun up, the same persistent volume will be bound to them, the MongoDB will be run on it, and your client will be able to connect to it using the same DNS name. This makes reliability in the face of failure much easier than on static hardware. It's because of features like this that we've seen such enormous growth in demand for Kubernetes in recent years. And by integrating with Ops Manager, you get all of the monitoring, backup, and automation features that you're used to on premises. You can download the MongoDB operator from our GitHub today. It's released in beta, and we're eager for your feedback. You can join our Slack channel, which is available again from our GitHub. We're very eager. If Kubernetes is your platform of choice, we want to help you scale, backup, and run your MongoDB clusters there. Thank you.
Thanks, James. No matter where you want to run MongoDB, whether it's on your laptop, on a private cloud, or in a public cloud, we want you to have an unbelievable experience building, maintaining, and managing your MongoDB cluster. So there's one more place that you can't run MongoDB. So here's some Java code, standard app server Java code. You can run this on any Java app server out there. But it'd be really cool if you can take this exact same code that you run in your app server and run it on your phone. So MongoDB 4.0 has support for MongoDB Mobile. So MongoDB Mobile is an embedded version of MongoDB that can run on any iOS or Android device so that you can have the exact same development experience using MongoDB that you have on the server side, exact same experience, all the same feature sets, directly on your phone, on any iOS or Android device. And to show you how easy it is to use MongoDB Mobile, I'm going to have Drew give you a demo.
Thanks, Eliot. I'm excited to show all of you a brief demo of MongoDB running on a mobile device. So for our Swag store, we'd like to deploy a mobile app. It's an inventory scanner, and it will let us do a better job with stock tracking. So it's pretty straightforward to write an app that can store scans from a mobile device on a remote app server, but sometimes you might not have signal, right? So maybe you're working in an inventory center, and there's zones without coverage. When that happens, we don't really want to fail the scans that we're trying to do. It'd be better to store them locally and then sync it up later. So let's look at how the app would actually do that. So if you look here, I'll highlight it quickly. This should look pretty familiar if you're using the Java driver. We're just importing some basic classes from the Java driver. And if we scroll down a little bit, you can see that we're going to do a find one and update. That also should look very familiar if the Java driver is something that you know. In this case, we're not actually using the Java driver to talk out to a remote MongoDB. We're using it to talk down to MongoDB compiled as a library and running on the device. So let's give it a try. All right, so you can see down at the bottom, a little small, but it says that it's running Gradle. We should be building the app now. Hopefully it'll be transferring over. As we mentioned earlier, live demos are always exciting. To reiterate, this is actually built as a library, so we are not talking out to a server. This will be running on the phone. Okay, great. We're up to installing APKs, so looking good. And installing APKs. I have an exciting barcode to scan on this bottle of water as we continue to install APKs. Still needs a little pruning down. Well, let's see if we can run it on the device, even though it's still installing. All right, we'll see if we can scan this barcode. All right, it looks like we captured one, and we have some log output down here. So you can see actually that this looks exactly like a normal JSON object that you would expect to see in a database, but we've persisted that locally on the phone. And obviously it's not just inserts. You can use it for anything that you would normally do with MongoDB. It's basically the full power of the MongoDB query language, but on your phone. And that's it. Thanks.
Hey, Drew, I thought you were going to cover syncing.
Elliot, I have this terrible syncing feeling that we were going to do that next year.
Can you guys go back to the slides for a second while we confer for a second?
Are you sure you want to do this? I mean, we've already demoed everything but the kitchen sink.
All right, well, let's see what we can do. All right, so we got the slides up. Can you give Drew a round of applause, please?
And let's pull it off. Thank you, sir.
All right, hold on. Let's see what we can do. Let's see if we can make this sync somehow. All right, let's go back to the demo and see what happens. And if you could put the other phone up there as well. All right, so what I have here is I've got this phone, and I've got an same application running in an emulator. So I got the real phone on the left, the emulator on the right. And I'm going to go ahead and scan this barcode again on this side over here. And stock gets updated to 3. And then on the emulator, it gets updated to 3 as well. So that's kind of cool. Now I can go and purchase one of these things. So the inventory on the emulator goes to 2, and it goes to 2 on the real device as well. And we can keep doing this. Oh, it restarted because I finally finished installing. We're going to do it again. All right, now we can't buy anything because we're out of stock. And they both say 0, so we can't buy anything. Let's put it back in stock. Oh, look, it works. It works. There's one there and one over there. So now we've got this data synchronizing between the mobile Mongo running on the phone and mobile Mongo running on the embedded device. So what did I do? And all that typing I did in those 5 seconds. Well, I really made one call to sync. And sync is a method on the collection. And sync is not something I wrote in those 5 seconds. That would be cool if I did. And it's not something we wrote for this demo. Sync is actually a method as part of the 4th service in terms of MongoDB Stitch, which is Stitch Mobile Sync. And Stitch Mobile Sync does exactly what it sounds like it does. It's a Stitch service that synchronizes data between MongoDB running on any mobile device and Atlas and any other mobile device. So you can build online and offline applications incredibly easily. All you have to do is add this one method call to your mobile application. So you call sync, you give it the document ID you want to synchronize, a conflict resolver, so that if you update the document in the cloud or on 2 devices at the same time, what do? And this just lets the application do whatever you want. You can just do last write wins, you can ask the user what to do. You have full control on the phone, and then event listener, so you can do something on the device, pop up a message, make the phone vibrate, something like that. Then every time you do a read or a write of that data on that mobile device, it will know to use the local copy instead of the remote copy. So if you're building an application and you want incredibly fast local performance or offline performance, you just synchronize the documents you care about. And that's it. You keep writing your application. And Stitch will automatically synchronize all those changes. So how does this work? So you're going to build your application just like you would on your phone. You're going to use MongoDB. You're going to go through Stitch. You're going to have this change stream behind the scenes, taking every change that happens in your Atlas cluster, pushing it through Stitch directly down to the mobile device. Very cool, incredibly easy to build online and offline applications that are incredibly fast. So we talked about 3 services in Stitch today that are all GA. Mobile Sync is the 4th. It is not GA today. Sorry. It is in private beta, though. So if you want to start playing with it and see how easy it is, come find us. We'd love to talk about it. MongoDB Mobile, where you can just run MongoDB Mobile on your phone, is in a public beta, so you can start using that today if you want to start developing an app against that. So lots of places you can now run MongoDB that you couldn't run it before. You have a free tier available on Google Cloud, cross-cloud coming later this year. You can now use Ops Manager and Kubernetes together to build and manage really cool Mongo clusters in your own private cloud, and mobile sync. So lots of great stuff there. So to recap a little bit, we've talked a lot about MongoDB Stitch, right? So Stitch is GA as of today. Stitch Query Anywhere lets you run MongoDB queries on any device with the full power of MongoDB. Stitch Functions lets you run functions in a serverless environment, and then you can use triggers to trigger these functions, and you can run these functions many other ways as well. And mobile sync coming a little bit later. In MongoDB Atlas, we have full CRUD support, so you can work with your documents directly in the Atlas UI. You have global clusters, so you can read and write data around the world with incredibly low latency. Free tier and GCP here as well. And we've also announced today, in GA today, a number of enterprise security features. We've added support for KMS, so you can actually use your own keys using Amazon KMS in order to do encryption at rest in Atlas. You can use your own LDAP servers to do database authentication to your Atlas clusters. And you have full database level auditing available to you in MongoDB Atlas. And also, we're super excited to announce that that Atlas is now HIPAA compliant, and we're also now signing BAAs for anyone who needs them. And we also have live sharded import, so you can do that as well. So you can take your existing sharded MongoDB clusters that are not running in Atlas and migrate them live into Atlas with almost no downtime. And in core MongoDB itself, we've added a number of improvements to the query language. We've also added a free monitoring service. So if you're using MongoDB on your own, and you want us to sort of provide some guidance on indexes or query performance or what's going on, there is now an incredibly easy to use free monitoring service directly built into MongoDB, where you just turn it on in the shell, and then you get sort of a free monitoring service. You can go and look at your data, or not look at your metrics and understand what's going on. And last, but certainly not least, are multi-document ACID transactions. So have we forgotten about those in the last hour? So MongoDB is the best database for modern applications. The best way to work with data, the best at making leverage of distributed systems, and you can run it anywhere. If you want to learn all about how you can use MongoDB 4.0, please take the MongoDB 040 course on MongoDB University. Check it out and play with all the cool new features. I really hope you've learned a lot this morning. I hope you're excited about all the new features that we've talked about. I'm pretty ecstatic about most of them, all of them actually. And I really hope everyone has a really great day at MongoDB World. I wanted to thank everyone who's helped put this talk together and all the demoers who frantically were dealing with AV issues during the talk, as you may have noticed. And I wanted to thank everyone for coming and spending the day with us at MongoDB World. And I hope to talk to as many of you as possible, and have a great day.